Hello and welcome back. Today I'm going to try and explain the technology behind Orbit Communicator, which is Orbit Framework, what the technology does and why I find it so interesting. So I'm starting off with two browsers. One's Google Chrome and the other is Chromium. So they're both connected to the same profile on the back end, but they are physically different browsers. So if we take a look at the calendar to start off with, what I'm going to try and do is create a new event here. What I'm interested in is a lag between the two screens. So if we add that time to be 12 o'clock, save. Okay, so I'm looking here, there we go. So within 3 or 4 seconds we've got the event being duplicated on the other screen. So the two views on the same data set, there's a few seconds lag for a create new event. So if I move that to a different day, I'm waiting here now for this to move across. There we go, that's moved as well. Again, a few seconds worth of lag. If I delete that now, I'm waiting for that to disappear. 6, 7, 8, 9, 10, 11. Okay, so there's a bit of a longer lag for deletes. Okay, it's gone. So we've got a reasonable degree of synchronization between the two views on the same data set, but it's not instantaneous. So and whether that's acceptable, I guess, depends on the application. But just to look at a comparison, if I switch across to two different views of the same Orbit Communicator, if we come down to one of these and say create a new event, we'll start it at 2 o'clock in the afternoon, 2:30 in the afternoon. We'll run it for 3 hours just so it gives us something to look at. My new event, just a test. So I'm looking for how long it takes to appear here on the second screen. Okay, so that was relatively instantaneous, and you'll notice it's also appeared here in my schedule and here in that schedule. So if I just edit this for a second and try and make it a bit different, if I make that an alarm, I should be looking for a change here and a change here and a change on this hidden screen as well. So if I do an update, if you watch there, that's now a little alarm clock, as is the alarm clock here, and we've got an alarm clock here. Now if I do something like moving this, if I shuffle this down by an hour, that was instantaneous. If I move this back up and make it overdue, a number of things that should happen, including a chime on the alarm, but it should appear at the top of the schedule, hopefully, and it should appear in red, and of course it should shuffle across on both screens. Okay, so the move there was instantaneous and the shuffle there was instantaneous, and the point first of all is there's no lag. It's effectively happening in real time as a push from the server rather than comparative technologies that tend to poll the server saying, have you changed yet? But the main point is that under the hood, in terms of what the framework is doing, when I literally drag and drop a calendar event, the only work that the application has to do is effectively to write a new record to the database saying this is the new time for the event. All the updates to the screen in question and to any other screens are automatic. So effectively the framework is working out who is connected to the dataset, what they've got on the screen, which parts of the screen relate to changed data, and when something changes, automatically change the display to reflect what's now in the dataset. So just a brief overview, but hopefully that gives you an idea of the difference technology-wise between what I would, I don't know how Google works under the hood, but I'm presuming it's a polling framework. But the difference between big technology frameworks and what can be done with what is effectively a real-time framework. Oh, and it wouldn't be a fair test really if I didn't delete that event just to show the delete lag. So delete and delete, and it's gone. Okay.